will discuss some question of linear algebra. Today's goal of this lecture is, at first I will see one basic question as a review of Nilpotent operator which had come CSIR NET exam. Okay. Second goal of this lecture is system of linear equation. I had seen in my previous video what is the system of linear equation and when system of linear equation has a solution, has no solution. This topic I have discussed in my previous video elaborately. Today I will discuss some question of system of linear equation which had come in CSIR NET exam again. Because I have told you actually the system of linear equation, this concept is very important for CSIR NET. The system of linear equation Ax equal to b is said to be consistent if it has one or more solution. And the system of linear equation Ax equal to b is said to be inconsistent if it has no solution. That means a system of linear equation cannot have finitely many or more than one number of solution. Always there exists either no solution or one solution, means unique solution, or infinitely many solution. Okay? It cannot have finitely many or more than one or two solution. Why? At first see this as a review just for concept. Consider Ax equal to b has two solutions where obviously AB M cross N matrix and X belongs to Rn and B belongs to Rm. Consider this solution be x1 and x2 be the two solutions of this linear system of equation Ax equal to b. Then that imply Ax1 equal to b and Ax2 equal to b. Now we can write x bar equal to lambda x1 plus 1 minus lambda x2 where this lambda belongs to real number. Now multiply this equation by a, then Ax bar would be a times lambda x1 plus 1 minus lambda x2 where lambda belongs to real number. And since we all of us know Ax equal to b always linear equation, so by linearity just omit lambda in outside, then this would be lambda times Ax1 plus 1 minus lambda times Ax2. And since the solution is such type Ax1 equal to b and Ax2 equal to b, just put the value, then this would be b and this would be also b. Then the equation reduces lambda b plus b minus lambda b, just cancel lambda b, then this would be Ax bar equal to b. So here I have considered two solutions, but I have got another solution x bar, and this x bar depends on scalar lambda. That means this x bar can be infinitely many. So system of linear equation, either there exists unique solution or no solution, or always there exists infinitely many solution. This cannot have finitely many or more than one number of solution. Are you getting? We all of us know this is. Just as a review, I have discussed this part, this concept again. This is our goal of this lecture. I will see one question of Nilpotent operator which had come in CSIR NET exam. The question is one question which had come CSIR NET December 2019 exam. The question is, consider one linear operator T from Cn to Cn which be a linear transformation for n greater than equal to 2. And suppose 1 is only eigenvalue of this linear transformation, then which of the following statement are true? Option 1, t to the power k not equal to identity for k belongs to natural number. Option 2, t minus identity to the power n minus 1 equal to 0 operator. Option 3, t minus identity to the power n equal to 0 operator, and this is true for all n belongs to natural number. And option 4, t minus identity to the power n plus 1 equal to 0 operator. This is very nice concept. This type of question actually very conceptual. Here have given this linear transformation, and here only one eigenvalue of this linear transformation. This is nothing but this is only one. And I will say here actually the operator t minus identity is nothing but this is actually nilpotent operator. Why? Because say here the linear transformation map from Cn to Cn with 1 as an eigenvalue of this transformation. Okay? Since for this linear operator only 1 be an eigenvalue, so if we consider this operator be identity, obviously this operator be always eigenvalue, only eigenvalue is 1. So t equal to identity, that imply obviously t to the power k equal to identity. So obviously option 1 is wrong option. T to the power k not equal to identity for k belongs to natural number, this is obviously wrong option. And notice here has indicate t minus identity to the power n minus 1 equal to 0 operator. Since here for this linear transformation only eigenvalue is 1, so t lambda imply here 1, here for this linear transformation only eigenvalue is 1, and the eigenvalue of this linear operator t minus identity always would be 0 0 0. That means obviously since the given operator t has only eigenvalue 1, that means the operator t minus identity has, since only eigenvalue 0, we all of us know in nilpotent operator has only eigenvalue 0. So obviously this operator be nothing but only nilpotent operator. Okay? Now let's see the option. See this option. Here t minus identity to the power n minus 1 equal to 0 operator. Here t minus identity to the power n equal to 0 operator, and this is true for all n belongs to natural number. And here given t minus identity to the power n plus 1 equal to 0 operator. Okay? This is the nilpotent operator. So obviously t minus identity to the power k, where k be any index, would be 0 operator where k belongs to natural number. And k depends on the dimension of the domain space. Okay? So here this operator depends on only index. That means I will get such type of k. But in the question has given minus identity to the power n equal to 0 operator, and t minus identity to the power n minus 1 equal to 0 operator. If there exists any k where k less than n, then that imply obviously always t minus identity to the power n plus 1 and equal to 0 operator, and t minus identity to the power n equal to 0 operator. But we can consider different type of k. Here k be the index. Consider on linear transformation such type, here all diagonal be the 1 and off diagonal be the 1. That means this is actually nothing but, this is actually Jordan block of linear transformation T with eigenvalue 1, and here the Jordan block of order n. Okay. Then obviously T minus identity is nothing but 0 on the diagonal and off diagonal contain only 1. That means for this operator T minus identity, obviously this is actually, notice, nilpotent operator with Jordan block of order n. That means T minus identity to the power n equal to here 0 operator. Okay. That implies from this operator T minus identity to the power n minus 1 is not equal to 0, because T minus identity to the power n minus 1 means this is, since this is the Jordan block of order n, this cannot be 0. So for this operator we can tell option 2 is a wrong option and option 3 is the right option, because since this is the Jordan block, that means actually this is the minimal polynomial of this operator. We all of us know minimal polynomial actually depends on Jordan block. So obviously for all cases, since here only possible highest degree of linear nilpotent operator of index n, so T minus identity to the power n plus 1 equal to 0 operator, this is always possible. That means option 2 is a wrong option and option 3 is a right option also. Option 4 is a right option. Are you getting this question? Oh well. This is very conceptual question. Okay. Now I will say one question of non-homogeneous equation which had come December 2017 exam. The question is, consider AB and M cross N matrix. Here the rank of the matrix is R. Then system of linear equation AX equal to B has a solution for each B belongs to Rm. Notice here this system of linear equation has a solution for each B. Okay, that means here B obviously belongs to column space of the matrix M. Here the matrix is denoted as A. Where AB M cross N matrix, we all of us know for every vector space has a linear transformation, and here the linear transformation is look like such type T be a linear mapping from Rn to Rm. Okay, this linear since here the matrix so denoted as A, that means A be linear mapping from Rn to Rm, and since here given rank of the matrix is A equal to R, but here also given there exists solution for each B belongs to Rm. That means since there exists solution for each B belongs to Rm, that means obviously this linear transformation be onto linear transformation. Are you getting this question? I hope my all viewers have understood. Obviously this is onto linear transformation. That, and we all of us know rank be the subspace, so always rank would be less than equal to M. Okay. Now let's see the option. Option 1, M equal to R. Option 2, the column space of the matrix is a proper subspace of Rm. Option 3, null space of matrix A is non-trivial subspace of Rn whenever m equal to n. And option 4 implies when m greater than equal to n, that implies obviously m equal to n. Okay? Since this linear transformation be onto linear transformation, that means these are obviously should be equal to whole codomain space, that means this is equal to m. So option 1 is a right option. True, because our given linear transformation be onto, otherwise this is not true. And by this knowledge we can tell option 2 is a wrong option, because here given the column space of the matrix A is proper subspace of Rm. Since matrix is onto, so column space means obviously this is the rank. Since the matrix is onto, so obviously always rank would be equal to m. So column space of the matrix A is proper subspace of Rm. This is not possible. So option 2 obviously wrong option. Okay. Option 3, notice the null space of the matrix is non-trivial subspace of Rn whenever m equal to n. This is also wrong option. For this, consider this mapping, this matrix, and here notice here this is 2 cross 2 matrix. So m equal to m equal to n, and since this matrix is invertible, so obviously rank of the matrix is 2. That implies null space of this matrix is equal to 0. That means null space of matrix A is non-trivial subspace of Rn whenever m equal to n. This is also wrong option. And option 4 implies if m greater than equal to n, that implies obviously m equal to n. Is here I have got rank of the matrix is m. Means rank of the matrix is m. Also we all of us know rank of the matrix is minimum of m comma n. That means obviously always would be m less than equal to n. And when given m greater than equal to n, then combine these three relation that imply m equal to n. That means if given m greater than equal to n, that means this is true when m equal to n. So option 4 is a right option. I hope my all viewers have understood this type of question. This type of question actually very basic question, but now I will see one question which had come CSIR NET June 2016 exam. The question is, let A be n cross A matrix and B be an n cross 1 vector with real entries. Suppose that Ax equal to B, where x belongs to Rm, admits a unique solution. Then we can conclude that option 1 m less than equal to n, option 2 n greater than equal to m, option 3 n equal to m, and option 4 n greater than n. This is obviously very easy type question. Here A be n cross A matrix. That means obviously there exists a linear transformation. Obviously this is denoted as A from Rm to Rn. And here given the solution always be unique solution. That means obviously rank of augmented matrix would be rank of A, and since this is unique solution, so this is equal to number of unknowns which is equal to m. That means since there exists unique solution of this matrix, so obviously rank of the matrix would be number of unknown which is equal to m. But here given, notice this option, m less than equal to n, n less greater than equal to m, n equal to m, and n strictly greater than m. Here given, no, rank of the matrix A would be always less than equal to minimum of m comma n. Okay, so m always less than equal to n. That means option 1 is a right option. Okay, well, I will stop here. In my next video, I will discuss this type of question again, because I have told you many times, actually linear algebra is very important for higher study. Also not only higher study, for competitive exam. Okay, so if you don't see my previous video, at first see my previous video, then today's video would be so easy. See you soon. Stay safe and stay positive always. Thank you so much.